Hi everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to see one more example problem on completely randomized design. Already we discussed a completely randomized design is one of the simplest design of experiment design, which is used in statistic, particularly in agriculture and biological research. In this design, treatments are assigned to all the experimental units completely at random. That means each unit has an equal chance of receiving any treatment here. Now we are going to see one more example problem on completely randomized design. A completely randomized design experiment with 10 plots, 3 treatments gave the following result. Here we are having 10 plots and we are giving treatment ABC and calculating its yield value. So in plot number 1 we have given treatment A and its yield value is 5. In plot 2 we have given treatment B and yield value is 4. In plot 3 we have given treatment C and its yield value is 3 here. Likewise, we have given treatment ABC in all 10 plots and calculating the yield value. Now we are going to analyze the results for treatment effects. Analysis of treatment effect. We have segregate treatment A, B, C and its yield value. In treatment A, we have given for plot number 1, 4 and 7, 9. We get the yield value is 5, 7, 3, 1. So, we collect treatment A yield values and likewise B and C yield values here. After that, now framing the hypothesis part. Here we frame H naught. There is no significant difference between the treatment effects. After that we frame alternative hypothesis, let it be H1. That means there is a significant difference between the treatment effects. Now we calculate its table values. In previous problem they have given the data in 2-digit value. So we shift the origin into the 10, convert into single digit. It will be easy for calculation. Here they have given single digit only, so we no need to shift the origin here. So we take x1 is nothing but treatment A, x2 is nothing but treatment B and x3 is nothing but treatment C. So after that we calculate the total value and x1 square, x2 square, x3 square. After that we sum of x1, sum of x2, sum of x3 and total value and sum of x1 square, x2 square and x3 values. After calculating these values, now we are going to analyze. In step number 1, here we are having n value is equal to 10. After that we find t value. T is nothing but total value of all the observation. After that we have to calculate the correction factor t square by n value. Now next we are going to calculate TSS value. TSS value is nothing but summation of x1 square plus summation of x2 square plus summation of x3 square minus t square by n. By calculating this value we get 40 here. After that we calculate sum of squares between the treatments. That is take it as SST. That is equal to summation of x1 the whole square divided by n1 plus summation of x2 the whole square divided by n1 plus summation of x3 the whole square divided by n1 minus t square by n. T square by n is correction factor here and n1 is nothing but number of elements in each group. So we substitute the values here. We get SST value is equal to 4. Now we are supposed to find SSE. SSE is nothing but TSS minus SST. Already we found TSS is 40 and SSD is 6. So by subtracting we get 34 is the SSE value. Now we are going to the ANOVA table. ANOVA table includes first source of variation, sum of squares, degrees of freedom, mean square value. Then we have to calculate F ratio value. Here sum of square we take between the treatments, which will sum of square value is SST here, degrees of freedom column minus 1 we get 3 minus 1 which is equal to 2, and now we calculate MSE value. SSE divided by corresponding degrees of freedom we get the MSE value. Likewise we have to find the error and SSE value. Next we have to calculate MSE value. MSE value is SSE divided by corresponding degrees of freedom we get MSE value. Now we have to calculate F ratio value. MST divided by MSE we get points 0 point something 6 something. Here the F ratio is less than 1, but F ratio should be greater than 1. So numerator must be greater than 1. So we have to calculate F is nothing but here MSE divided by MSD, that is equal to 1.92 here. After that we have to calculate the corresponding table value, F table value. F table value is here F table value is here 19.35. So here coming to the conclusion, calculated F value is less than the table value. So here we accept the H naught. That means there is no significant difference between the treatment. Thank you.